4.3b. Okay, we're going to start off with a function, let f of x equals x squared minus 4 on the interval from 0 to 3. So I drew from -4 to 5, from 0 to 3. So we input 0. 0 gives us -4. I input a 1 because I'm going from 0 to 3. I put a 1 in there and we get -3. We put a 2 in there, we get 0. And we put a 3 in there, we get 9 minus 4, which is 5. So let's plot those points. F of 0 is -4. F of 1 is -3. F of 2 is 0. And F of 3 is 5. Okay, so let's draw the graph. Go through the points. Okay, so if we integrate, we'd be looking at the area under the curve here. So I'm going to put, I'm going to call it A1 for area of 1 there. But if we were to go down here, we have no boundary. So that's not going to work. So we're going to go and find the area here. Okay, so I'm going to call that A2. We're going to add the two areas up, and that would be the answer from 0 to 3. Now we have an issue here because when we find area here, we're doing a positive number times a positive number. It gives us a positive. But here, if you notice, here's a positive, and then we go down to a negative, and a positive times a negative is negative, and we can't have negative area. So when it comes to finding this out, we're going to have to use the absolute value sign so we get rid of that negative number. All right, so how we integrate this is we split it up in two portions. So to start with, we'd say we're looking from 0 to 3 of x squared minus 4 dx. Okay, we're going to split that up right here from 0 to 2 and then from 2 to 3. So 0 to 2, and then we're going to add that from 2 to 3. Okay, and I'm just going to write x squared minus 4 dx, x squared minus 4 dx. But remember, this part needs to be a positive answer. So you can think of it as doing the absolute value of this one and adding it to the next one. Okay, so first we're going to integrate right here. So integrating x squared minus 4, we're going to add 1 to the 2. We get x3, and then we divide by that number, and then minus 4x. Okay, and we're going to integrate from 0 to 2 and absolute value that one. Okay, integrating the next one, it's the same integration. x3 over 3 minus 4x, and this one we're doing from 2 to 3. Okay, so let's do this one from 0 to 2. Put my absolute value bar here. Okay, so we're going to put a 2 in there, so we have 2 cubed over 3 minus 4 times 2. All right, and all of that is minus 0. Think of it this way. And we put 0 in there. 0 cubed over 3 minus 4 times 0. That is my cat playing with my pen. All right, so all of that is this right here. And I'm going to do this one over here. Okay, so this one over here we have, going to put a 3 in there. 3 cubed over 3 minus 4 times 3. All right, and then we're going to minus, and we're going to put a 2 in there. So we have 2 cubed over 3 minus 4 times 2. Okay. All right, I'm going to erase this now, and we're going to continue on with this problem. I'll just keep this picture up here while we work on this problem. Okay. All right. So what we end up with, we have 8/3 minus 8. All right. Plus, and then we have 1/3 at 27/3 minus 12. And that's going to be minusing 8/3 minus 8. Okay. So what do we have here? Well, we can think of this as 8/3. We need a 3 in the denominator, so we multiply this by 3. Okay. Plus, this right here, we have 27/3 minus 12 minus 8/3 plus 8. So I just distributed that negative to both of these. Okay. Now within here, we have a -16/3, which is what we expected, a negative number. That's why we needed our absolute value sign. Okay. Plus 27 minus 8 is going to be 19/3. All right. -12 plus 8 is -4. And again, we can think of this differently too. This -4, if we put a 3 in here, we multiply 3 times 4, we get 12. Okay. All right, so here, this becomes a positive 16/3, and 16/3 is 5 1/3. So that's this area right here, 5 1/3 units squared. Okay. This one is 19 minus 12, which is 7/3. Okay. Now when we add these up all together, we get 7 2/3. All right. So this area right here was 7/3. And this area was 5 1/3. And we add them up together and get 7 2/3.